Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is Germano, Vice President of BEC Technologies, an expert on, experienced entrepreneur, venture capital expert, and 5G expert, I will say, a full thanks, which is a very hot topic right now. Thank you for joining us today, Andy.
Thank you. My pleasure.
Would you like to give us a quick introduction about yourself and your company so we can get started?
Sure. As you mentioned, entrepreneur, I've been in the telecommunications industry for over 30 years now, starting out with General Telephone, which is part of Verizon today. And then also worked for Northern Telecom and Qualcomm, number of startup companies, including Authentic, which IPO'd on NASDAQ and was acquired by Apple, and a couple other companies, Inside Secure. And then BEC, I started 20 years ago this year. So it's been an exciting time with the technology, as you mentioned, leading up to 5G.
Oh, well, that's some resume going on there. So, where to start? Maybe we can start by looking at the 5G landscape. How do you see that going? I remember 2 years ago, I was at MWC Barcelona. I missed out this year. But they might as well have retitled the conference as Monetizing 5G. Like, it was literally the only thing you could see if you walked around the floor. What's happened in the meantime? What do you think? Where do you think the market is going? Is adoption finally going up?
Definitely, the adoption's growing. I mean, I look at the some of the reports that come out from the analysts, and we're seeing a significant increase in the number of connections. I believe over a billion 5G connections already today. And so, in my business, I see a lot of demand for 5G, especially on the enterprise side, where companies want to invest in the latest technology. If they're investing, they want next year's technology, not last year's technology. That being said, 4G LTE still is a great technology, has long legs. It'll be around for a while. The components have come down the cost curve further, so it's in a lot of cases, depending on how much spectrum you have, you can get the same data rates for a much lower cost per components. So it's a good investment. You could do gigabit speeds, and in some areas, that's going to be similar speeds with a 5G connection. But I am seeing more demand around 5G, and then more adoption from 5G. And on the consumer side, consumers like the buzzwords. They like the 5G, the latest technology. People talk about 6G, even though that's a long ways away from today. But in a lot of cases, we work with the national carriers as well. The Verizon, T-Mobile, AT&T, US Cellular, and they talk about 5G on the commercials, but with the actual service plans, they tend to not emphasize whether it's a 4G or 5G connection, just that they have the best speed or they have the most efficient network. So they're not going into details on the actual service plan itself, whether it's a 4G or a 5G. But we're just seeing amazing speeds in wireless technology compared to before 4G came out, like the 3G timeframe. We've just gone leaps and bounds ahead. And then with 5G, it continues to advance. Like we're just now starting on the second generation of 5G. Just like in 4G, there were three generations. There was LTE, then LTE Advanced, and then LTE Advanced Pro, with each generation getting faster and faster speeds, starting with 100 megabits and 150, 300, and then finally with Advanced Pro all the way up to gigabit, over gigabit speeds. And then 5G, we're just seeing the second generation now shipping components for the what they call 5G Advanced. And then soon we'll see this thing called RedCap, which is actually using IoT, Internet of Things type of connections, technology that's optimized more for the IoT using 5G technology. So certainly, lots of evolution has happened, and lots more is in the pipeline on the way.
That's yeah. I think now that we make me think of it, I've seen their advertisements go from explicitly mentioning 5G to America's fastest network, America's most reliable network. Or they don't say 5G anymore. You're absolutely right.
True.
So, what do you think the actual impact of 5G will be on wireless technologies? Like, what are the sectors to stand to benefit more from actual 5G rollouts?
Sure. Well, initially it was the faster speeds, and then everybody always looks for what's the killer application, what will make First, the carriers, the wireless operators, and then the consumers and enterprise invest in the 5G technology. Usually, when a next G comes out, it tends to be more expensive in the first couple of years until the volumes and volumes go up, component costs come down. So there always has to be a driver, and it's interesting. The initial use case for 5G driver was fixed wireless, which happens to be a business that my company, BEC Technologies, is a leader in fixed wireless technology. So we have seen a lot of adoption by not only the regional carriers that were more popular with fixed wireless, but also the national carriers. Verizon and T-Mobile have added, millions of connections. In fact, I was at a conference, I think it was first quarter last year, where T-Mobile was on stage saying that they actually added more new connections in the first quarter of 2023 than all the cable companies combined. And if you go back to the beginning of internet, the internet was originally led by the AT&T and Verizon with wired technology, ADSL, VDSL, ADSL2, 2+, fiber to the home, etc. But then with cablecos or MSOs, as they call them, they took over the internet and became the majority suppliers. It was the first time really that wireless technology had outsold the top selling internet technology in terms of new connections, which was T-Mobile's announcement last year over the cable companies. So we have seen some adoption of wireless technology from the cable companies as well. There's a new technology, yes, about 5G with private networks. It's not specifically a 5G technology, but the speeds get better with 5G, of course, and then also the number of connections are higher. The latency goes way down. So in my business, we're starting to see a lot more. There's downlink and then uplink with internet. There's data coming down to your computer, and then there's things you're sending up, like video streaming isn't a good example of an uplink heavy technology. And with 5G, we see much better uplink connection speeds with the advanced antenna technology. Multiple input, multiple output, or MIMO technology allows for much higher connection speeds. And we see those number of MIMO connections going up. We see advanced technologies at cell tower base station sites where there's high-end arrays like 64 by 64 element antenna arrays, which allows not only beam forming, so you can get a more precise beam to an area, so you can get more signal or more spectrum towards a specific user that needs it at a specific time. But it's not only beam forming, but it's also beam steering. So let's say I'm here doing this uplink video call right now, so I'm needing more beam on me, whereas before the power was being sent in all directions equally, whether you needed it or not. So now, after this call is over, I might just go and have lunch, and so I don't even need any internet at all at that time. So the beam can not only be formed, but it also can be steered and used by somebody else. So it's really interesting technology. So it makes the amount of spectrum that you have at your disposal, it allows you to be so much more efficient with it, and it allows the users to get a much better experience. And the latency is important, where if you can, with internet, if you can move connections on and off a lot faster, then those connections are going to be a lot more efficient, and you'll get an overall increase in capacity. There's a lot of under the hood type of technologies that 5G brings to the table that makes it much better, much more efficient technology. And then, as I mentioned, with this red cap, it also focuses on the Internet of Things connections, because with 5G, there's so many more simultaneous connections that are allowed and available. So that allows you to connect more things to the wireless network.
Yeah, the IPv6 adoption is still underway, but eventually we'll get there. And I think it's so.
Exactly.
One thing you mentioned that's really interesting to me is private networks. What's a 5G private network? How does that look like?
Yeah, so private network is interesting. So that is another thing actually enabled by 5G technology, is something that they call network slicing. So there is a slice of spectrum that's widely used currently. It's 3.65 gigahertz, and in the U.S. it's called CBRS, but it's also called ONGO. And then in other countries, there's other slices of private spectrum potentially available. And so that allows just businesses, kind of like Wi-Fi, where you don't need to work with a national carrier to put your Wi-Fi network. It's just public frequencies. And so the public private networks use case is there is a spectrum sharing, a spectrum allocation system. So it makes it better than Wi-Fi in the sense that it's more secure, but it's also the spectrum is allocated to you at a specific moment in time. Whereas in Wi-Fi, it's more of a collision avoidance technology. So if you have a lot of Wi-Fi's on the air, like at a trade show, you'll notice that the speeds go way down because you might have like 5, 10, 15, 20 systems all battling out for the same airspace, the same spectrum, if you will. Whereas with the spectrum allocation system with these private networks, it allows one person to have access to that piece of spectrum at any given time. So there's priority access licenses where you own the whole chunk yourself. You can do whatever you want with it. You can even lease it from somebody else. And then there's also a GAA component, general availability, similar to Wi-Fi, where anybody can use it. And then the technology that that we build and that other companies build does that all automatically. So the private network owner doesn't have to worry about the spectrum allocation system or how it all works. You just plug it in, turn it on, automatically communicates with the spectrum allocation system or the SAS, and then it gets its spectrum, and then you have your own private networks. We're starting to see a lot of applications for private networks in ports. Ports are very busy places. There's a lot of security required. And then in a lot of cases, Wi-Fi wasn't reliable enough, or it was just getting too crowded, especially 2.4 gigahertz Wi-Fi. We did a project with a large carrier. It was basically a rock concert, out in the middle of nowhere. And so they wanted to use Wi-Fi for all their point of sale and for their security cameras and a number of other applications. And the network was all set up. Everything was working great. Luckily, we were using 2.4 and 5 gigahertz Wi-Fi because when all the bands showed up on concert day, like there's so many devices that are in the 2.4 gigahertz, Wi-Fi spectrum. Anything from I don't even know if pacemakers are in there, but I mean like all these, wireless microphones, wireless speakers, wireless this, wireless that. Plus, people bring their own little Wi-Fi hotspots, and so the 2.4 Wi-Fi was basically at a standstill or a crawl. The 5 gigahertz was much better because there's a lot more spectrum available up there, and more is coming. But we had set up a private network, so just to allow all the critical back office systems like point of sale could operate without worrying about security or collision avoidance type issues, so that we were able to have an efficient network. Because literally at these events, they'll do millions of dollars a day in beer sales. So not only that, merchandise and everything else, but it is a unique application. But we've seen ports, we've seen a lot of industry. So like Industry 2.0. In building applications. So in building, you don't really need a very far propagation, but you need a very efficient propagation. With machines, you need very low latency, which 5G brings to the table. But all that being said, with private networks, getting back to what we were talking about, network slicing. So 5G actually enables a technology called network slicing, where carriers that have excess spectrum don't need to use that public-private 365 spectrum we talked about, but they can actually allocate a piece of their license spectrum and slice it off to a specific industry or a customer. So it has the appearance of a private network, even though the service is actually coming from a public carrier, if that makes sense.
Yeah, it does. It is. It's a very interesting proposition because, in my opinion, it feels like it's all this kind of network slicing, especially, opens up a world that wasn't available to smaller players previously. Again, if you can strike a deal with the carrier, whatever. For example, someone like SignalWire was not a small company, but not very big either. Could get some kind of internal network sliced out of a larger network and use that for their own usage without having to invest in effectively an MVNO style setup. So
Exactly.
would that be like
It's like a build versus buy? Yeah, build versus buy business case. So you want to do that business case and say, does it make sense for me to put up my own towers, put up my own base stations, or radio access network, or if I need a core network in the back, and then I also, of course, I need the devices. So do I want to do that, manage that, have staff to take care of it myself, or just outsource it back to the carrier? And from the carrier's perspective, they may be in a busy area like, let's say, New York City or Los Angeles, where they don't really have excess spectrum, so they're just not going to sell private networks off their public spectrum in those busy areas. But then they have the same amount of spectrum in a more rural or suburban area. They have excess spectrum, so why not? You put it to use, and then it's kind of a win-win. They still manage the network. They're the network provider. They get the monthly recurring revenue, and then it saves the business from having to build and manage everything themselves. So it's definitely a make versus buy business case. Some will go ahead and build their own. We're working on a project right now with a large railway for railway crossings and managing devices across the country, and it's a great kind of a public private. We work with a lot of utilities who bought their own spectrum, so we're doing a combination public private. So they want to have private, they want to have full control, full ownership for security and other reasons, business case reasons. But then it's going to take them years to build out their private network. So they have a kind of a hybrid network approach. Today it's more public, and then as the private network gets built out more and more, those same devices can evolve from being on the public network to evolving over to their own private network. And that saves them the monthly recurring fees. They had just have the capital expense investment of what they're building to have that private network in place.
So, what's the difference between acquiring a network slicing network and having your own MVNO? I suppose the latter is far more involved. What does being an MVNO give you over just using slicing?
Yeah, I mean the MVNO is really a contract more than anything. I mean it is nice because it's just add water. It's instant. It was interesting. Like when this private network was first being discussed before it was even called CBRS or OnGo. The previous generation technology was, a lot of companies were looking at it, and everybody thought, oh, Google's going to become a network operator, or Facebook's going to become a network operator. And then I think what a lot of people didn't realize is the billions and billions of dollars of investment that AT&T, Verizon, and T-Mobile have been making over the past decades. Really since like 1G, 2G, 3G. I mean, that's an infrastructure that's not easily replicated. We've seen a couple of projects like Google Fiber and things like that, but it would be very difficult to just become a national carrier. I mean, it would take so much investment. Look at Dish as an example. They've invested millions and millions of dollars, building out their 5G advanced network with standalone architecture. And it's a challenge to build a nationwide network, even owning all that spectrum, and you have to build all those towers, put all those radios up, acquire the customers. So the MVNO is kind of just add water, and I'm a business kind of approach. So it's a lot faster potentially. Of course, then you have to revenue share, so you don't get all the revenue, but you have all the capex cost savings of not having to build out. I think I work with a lot of customers on both sides, national carriers as well as MVNOs, and from an MVNO perspective, I mean, just not having to build and manage and maintain those national networks is a huge business driver for them. And we work with a lot of managed service providers. These are companies that sell end-to-end solutions towards enterprise. And they have really great contracts with the national carriers, with AT&T, Verizon, T-Mobiles. So they sell the service plan, the SIM card. They manage everything, and a lot of times they don't even sell my equipment. It's just as a service. So it could be like a wireline backup. They use one of my routers to back up a wireline network, and they don't even sell my hardware or resell the hardware. They just charge a monthly fee, which includes everything bundled in. The hardware, the service, the maintenance, everything. And so it's a really great business. It's a multi-billion-dollar business, and it's a channel model. So it's really really interesting how these managed service providers and MVNOs are operating.
Yeah, and top of that, I feel like MNOs, managed services, you have a lot of freedom in what you can build. It's actually easier to patch into advanced services, try and do a man in the middle type of stuff like using transcription, early media, because all you got is some SIP pipes into the main carrier, which makes it actually not too complicated to build very interesting services. We've been working on a couple, and it's from what I see from the outside, so from perspective of someone who's supplying advanced services to these MVNOs, it doesn't look like it's too hard for them to get the service going. Then, of course, probably is. I just said something that's false, and people will email me saying, hey, you know what? We've been working on this for 6 months. Then that's it. It doesn't look like it's super complicated. It's certainly easier than standing up your own IMS, right?
Oh yes, yes, exactly.
That's nobody wants to do that. It is. I've been part of a team standing up a test IMS about a year ago, and that was work. Like we were doing that for learning purposes, and I'm not even sure we managed to learn much. It was so complicated that when it started working, no one was sure why. Calls were working. We were seeing terminals connect and calls go back and forth. Something we knew, something we just didn't know why it was working. So it's so complex that it's best left for two professionals for sure.
Definitely. Yeah, definitely.
So
Interesting.
in the hardware business, what do you think are the best sellers right now, if you can say? Like what's flying off the shelves?
Yes, so we actually are just starting a new business at BEC this year, which is ESS, Energy Storage Systems. So we've been extremely successful with LTE and 4G. Before that, we were extremely successful with wireline technologies like ADSL, VDSL, fiber to the home. But the 4G LTE business for fixed wireless has been huge, and also for Internet of Things and then enterprise applications. 5G continues to see large acceleration, more applications like with large utilities and different projects, unique private networks. We're very heavily involved in private networks, but energy storage systems is basically using battery technology to. I'll give you an example. Like at a cell tower site, you always want to have that backed up. Like if the power goes out, usually your cell phone still works, which means that your cell phone's obviously not plugged in. It's got a battery on it, so you can charge it from your car, or charge it. And then if the tower loses its power from the utility, it has battery backup. Just a simple example of where usually if there's a hurricane or a tornado, these cell phones are usually still on, whereas maybe the house phones are not. They're out for a longer period of time. So wireless technology is really good. And then here's another example. So electric vehicle charging stations. So we have what they call sustainable energy projects. This is where you can actually uh, you can charge electric vehicle charging stations from the grid, but you can also charge them from solar. So if you charge it from solar power, you have to store that energy in the batteries. So you have to have ESS on site at the charging station. So what we do is we use solar to charge the batteries, and then there's also grid power there. The other thing we can do with the ESS energy storage system is we can actually fill the battery off peak, so you're paying a lower rate, and then the charging might be used for the vehicle during peak periods, but it's energy that we actually acquired at the off peak period. So it not only helps balance the grid, but it helps to get a much more effective economic and gives an opportunity for a profitability for the service operator where they can buy power at cheaper rates and then sell it at the higher rate for the peak period. So there's a lot of things with ESS that we're seeing enabled. We don't see as much ESS in residential in the U.S. Because a lot of people in the U.S. will use generators, but in Europe we're seeing a huge amount of ESS. And then in Asia, we actually have done a lot of factories where you have semiconductor factory. So if there's a power blip for any reason, an earthquake or a tsunami, a fab is basically the cost at any given moment in time is millions of dollars. So if the semiconductor fabrication gets interrupted, it's literally millions of dollars. So the ESS allows the semiconductor fab to be backed up at all times. So if there is an interruption in power, you don't lose power to the fabrication process. And these systems are huge. They're like trailers and trailers full of battery storage systems, energy storage systems, and they're literally millions of dollars projects, like $30 million for one fab to put their ESS system in. So it's kind of everything from like a small scale residential to a larger scale. And then the U.S., as I mentioned, generators for suburban or rural. But in metropolitan areas, you really can't have a generator to your apartment in New York City. So we're seeing a lot more of residential ESS for high end condos and high rise type buildings in larger urban type areas starting out now. So it's really interesting technology. It's evolving rapidly, and we see that as a big future for us. On top of the 5G router business.
Yeah, that's really very very interesting. And I think you're right. I'm from Europe. I'm from Italy, and around here, generators are much less used than batteries. Let's call them batteries of various types, and not all batteries. They're not. I know there's a difference, but we don't see many businesses even having generators on site. Most people prefer having large accumulators, as far as sorts, mostly because we have a lot of small solar around here. People who have, 6, 10 kilowatts of solar on the roof, even if it's the business. So it's a great way to smooth out the curve too. So it acts as a backup, but also acts as the best way to make sure you use all the energy from the solar plant from during the year and the day. So I think that's a very that's a probably the direction we're going in. Well, in general, batteries are going to be in high demand, right? It's always going to be in high demand.
Yes, yes, exactly.
Although we'll have to see what happens with AI now that people seem to be complaining that it's using a lot of energy until you realize that's not true. But it's hard, when the news gets out, then it's really hard to figure out what newspapers want to say sometimes. But the use of energy is actually not terrible. Bitcoin is far worse.
Sounds like a Johnny Depp sci-fi movie to me. I don't know.
Yeah. Okay. Yeah. Totally.
These-
Yeah.
yeah.
There's a revenge. There's a revenge somewhere in there of something against something else. Like
Yeah, I mean,
and there's
certainly AI might use a lot of energy, but I mean, electric vehicles are going to use so much more energy. There's really not enough power in the grid today. Just if we all went to electric vehicles, or even just met the presidential mandate for electric vehicles, which isn't going to happen, but there wouldn't be enough energy in the grid to supply the power for all those vehicles that soon. So there's a lot of infrastructure upgrades that need to happen and are starting to happen. And actually, speaking of government, there's a lot of government incentives for these ESS systems right now. You can get about a 30% subsidy from the government for installing these systems. So it definitely helps offset the cost.
yeah, there's going to be some kind of incentive. Although I feel like the sooner you can get a market off incentives, the better. We've seen what happens, in telco, especially in Europe, when you incentivize some deployments too much, and then you take
Sure.
away the money. Suddenly, we have a lot of 5G equipment lying around here, much more than in the US. That was, I think, it wasn't a subsidy; it was just a tax break over it, for in some countries. And now those carriers are rushing to see if there's a way to make people pay more for the services. And I think that's actually trickier than it sounds. That's why I'm always thinking about what can be the killer application. Maybe AI itself, I don't know. But the problem I think is, for me, if I'm watching a movie on Netflix over mobile, 4G gets me the movie fast enough to watch it on my phone. I'm not going to watch it at double the speed. It's
Right.
like one of those comedy movies from the start of the century where everybody was just moving faster because it was how it was filmed. It was making them look like they're moving faster, just how it worked.
Well, I'll give you an example. Data centers. So everybody's backing up their iPhones, subscribing to cloud, Google Drive. Backup this, backup that. Everybody has all their social media, the Facebook and the photos and the videos. There's so much data being created, and everybody wants to keep their data. They're not necessarily keeping it on their device anymore. It's in the cloud somewhere. But these cloud data centers, they actually use significant amount of energy, and that's another key area for ESS as well, because they have to be available, not only available at all times, but they can't afford to lose the person's data. That's the whole purpose of their existence, to maintain this data. So they're probably going to. I mean, AI kind of fits into that category because AI is probably living in a data center or many data centers. So it's just a part of the overall data center energy consumption.
We're moving around a lot of data. You're absolutely right. Just any iPhone or whatever has 128 gigabytes of memory on board minimum, meaning that most of that needs to get backed up somewhere. Then you want to download the backup from another device. You need
Exactly.
to back it up again. So it's easy to move a few terabytes of data just by using your normal device day by day. So it's really, yeah, speed is going to be important. And it's I think though it's right now it's still hard for the general public to perceive the difference. That's what the carriers are going after, showing that there's value in that, not just but it's tricky to tie that to 5G. So as we said at the start, they're just saying we have a better network. It's faster. They don't tell you it's 5G for because it doesn't matter too much.
Right. It's
What
just the
it
overall
is.
experience that matters. Yeah. If
Cool.
it's
Well,
fast, you're happy. If it's slow, they're not.
yeah, exactly. It doesn't really and that's hard to make people understand unless you can see it work. Like when you notice that something is low, you immediately notice it's really noticeable. So I think that what they're playing with is that. Well,
Exactly.
Andy, thank you so much for joining us today. It's not often we have someone who's an expert on hardware and the network technologies, and we went through a lot of interesting things, including the fact that your industry is going towards accumulators too. So there's a lot about this. The world is going back to electricity after a century where electricity wasn't featured in many discussions. We're just using it as a tool. Now it's going back to being a product, which is very interesting. It's a cycle.
True. Yeah.
So,
Yes.
Andy Germano joined us today, Vice President of BEC Technologies. And thank you for joining us today, Andy.
Thank you very much. Grazie mille.
I'll see you next week. Bye.